Spring is the time to say goodbye to winter. But as we say goodbye to winter, we also get a chance to say goodbye to the wintertime constellations that we see in the sky. As we orbit around the sun, they slowly disappear into the west and get lost in the glare of the sun. But one particular group of stars is particularly beautiful to look at, especially this particular April. Looking west, we find the familiar constellation of Orion the Hunter, and just a little bit to the west of it, Taurus the Bull. Now, if we draw a line through Orion's belt, we come to the star Aldebaran, the eye of the bull. If we keep going, we come to the planet Venus. And just below the planet Venus is one of the most famous star clusters in the entire sky. We call it the Pleiades, or the Seven Sisters. In Japanese, it is the word Subaru, and it has been observed, and stories have been made up about it for thousands of years by thousands of different cultures. To have a look at the Pleiades, we zoom in a little bit, and under really, really dark skies, we can see 5 or 6 stars. If we're under really dark skies, we can see 6 or 7. Galileo discovered more than a dozen, and a larger telescope will reveal more than 200. To the Pawnee people, this was the 7 brothers, which taught about getting along and unity. To the Greeks, it was 7 maidens who were pursued by Orion the Hunter, and were saved by the god Zeus by turning them into white doves. It was even mentioned in The Lord of the Rings as the netted stars. Look in the Fellowship of the Ring as the hobbits are leaving the Shire. To the Kiowa people, this were also 7 maidens who were out away from their camp and were chased down by a huge, huge bear. They climbed up on a pile of rocks, and the rock heard their prayer to rescue them and slowly began pushing itself up out of the ground into the sky. The maidens were sent into the sky, and the bear, in his anger, scratched the side of the rock, trying to repeatedly get to the maidens. And today, that pile of rocks is still visible in northeastern Wyoming. It is the Devil's Tower. Most of the stars in the Pleiades range in magnitude from 3 to 5. The star Polaris in the Little Dipper is about a magnitude 2, meaning not the brightest star. Most of the stars we see in this group, the Pleiades itself is over 410 light years away. That means the light we see from the Pleiades tonight left there 410 years ago. The 9 brightest stars that we can see are really, really hot young stars, blue giant stars that are very, very young, very, very new. But closer inspection reveals that there are some red stars in the group, but most of them are these young blue, very young hot stars. The whole cluster itself is about 7 light years across, and it's best seen with either the naked eye, a pair of binoculars, or a telescope at using the lowest possible magnification, because the beauty lies in the broad range of the cluster itself. The Pleiades is what we call an open or galactic star cluster, meaning these were all very young stars that formed at about the same time and from the same cloud of gas. The blue nebulosity we see here used to be thought of as the cloud that the Pleiades were born from. But in recent years, we've discovered that it's probably a cloud of gas passing between us and the Pleiades as the cluster moves through space. The Pleiades is a great opportunity to test out your binoculars or your small telescope and try to see how many different individual stars you can actually see. Each of the bright stars of the Pleiades also has a name. If we start with the brightest in this corner, this is Alcyone, Atlas, Pleione, Maya, Taygeta, Electra, and Merope. It's interesting to note also that Merope was the daughter of a famous king who she happened to catch the eye of Orion the Hunter. But that's a story for another time. So get out there tonight. Look to the west right after the sky has gotten nice and dark. Look below the planet Venus in the west and look for the Pleiades. This is Rod Kennedy with the Casper Planetarium, and we'll see you tomorrow with another astronomy podcast.